Hello, everyone. Welcome back to STEM Explained, where we break down big ideas in science and technology and show how they connect to our lives. I'm Rishika, and today we're digging into sustainability. But we're going beyond the basics. You've probably heard sustainability used everywhere, from social media hashtags to labels on coffee cups. But real sustainability goes much deeper than swapping out plastic straws. It's about science, technology, engineering, and even the mathematics that help keep human civilization in balance with our planet's limits. So, today we're going to explore what sustainability truly means and why it's so urgent. Sustainability is often summed up as meeting our needs today without compromising the ability of future generations to meet theirs. But that's just the tip of the iceberg. In scientific terms, sustainability means operating within the limits of Earth's natural systems. It's cycles of water, nutrients, carbon, and biodiversity that keep life stable. One of the clearest scientific frameworks for understanding these limits is the concept of planetary boundaries, developed by scientists like Johann Rockström and Will Steffen. They've identified nine critical Earth system processes, including climate change, biodiversity loss, ocean acidification, and nitrogen and phosphorus flows that have safe operating spaces. If humanity pushes past these thresholds, we risk destabilizing entire ecosystems and climate systems in ways that could be irreversible. Think of it like balancing on a tightrope. On one side is a sustainable future, on the other are tipping points, like collapsing ice sheets or mass extinctions that we might not be able to undo. That's the real stakes behind the word sustainability. For thousands of years, humanity lived in a world where natural resources seemed limitless. But the past 50 years have changed that. Global resource extraction has tripled since 1970, and yet Earth's capacity to regenerate those resources, forests, fisheries, healthy soils, has not kept pace. This is why scientists mark something called Earth Overshoot Day. Each year, the date when humanity's demand for natural resources exceeds what the planet can renew in a year. In 2024, that date fell in late July. So, for almost half the year, we're essentially running ecological deficits, drawing down the natural capital that should sustain future generations. Meanwhile, the consequences are visible all around us: heat waves, severe droughts, disappearing biodiversity, and rising seas threatening coastal cities. About 1 million species are now at risk of extinction. The science is clear. Continuing business as usual puts us on a collision course with these limits. Sustainability isn't just a buzzword, it's a survival strategy. So, how does STEM, the science, tech, engineering, and math, help us tackle this gigantic challenge? Let's dive into some cutting edge areas where advanced research and innovation are making a difference. First, we have clean energy and storage. Decarbonizing our energy systems is critical because fossil fuels provide around 80% of global energy. Solar and wind energy are expanding fast, but they're intermittent. The sun doesn't shine at night, and winds can die down. So, scientists are working on advanced storage technologies to smooth out these fluctuations. Solid state batteries are one promising avenue. Unlike regular lithium ion batteries, which use flammable liquid electrolytes, solid state batteries use solid materials that are safer and can pack more energy into smaller spaces. There's also research into flow batteries, which store energy in liquid electrolytes pumped through a system, potentially ideal for large scale grid storage. Even gravity is being harnessed. Companies like Energy Vault are building huge towers where heavy blocks are lifted when energy is plentiful, then lowered to generate power when demand strikes. Sustainable energy, sustainable industry, and materials. Energy production isn't the whole story. About 30% of global carbon emissions comes from hard to abate sectors like steel, cement, and chemicals. Take cement as an example. Traditional processes release CO2 both from burning fuels from the chemical breakdown of limestone into clinker, a key ingredient. Scientists and engineers are creating alternative cements that reduce emissions by substituting clinker with materials like calcinized clay or industry byproducts. Some startups are developing carbon negative concrete where the cement actually absorbs CO2 from the air over time, effectively turning buildings into carbon sinks. There's also major innovation in biodegradable plastics and new polymer chemistry. Chemists are designing plastics that break down naturally under certain conditions, avoiding the massive problem of microplastics in oceans and soils. And speaking of sustainable business practices, I recently interviewed the CEO of a startup called Micro that's working on making business processes more efficient and sustainable. Their company focuses on helping businesses analyze their entire operations to identify ways to cut energy use, reduce waste, and lower emissions, and save money. It's a perfect example of how STEM and sustainability are intertwined in building smarter systems that benefit both the economy and the environment. Next up, we have persistent agriculture and food security. Agriculture uses roughly 70% of the world's fresh water and contributes significantly to nitrogen and phosphorus pollution. But precision agriculture is transforming farming into a high tech industry. Using satellite imagery, soil sensors, and machine learning algorithms, farmers can map exactly how much water or fertilizer each part of a field needs. This reduces waste, cuts costs, and prevents nutrient runoff into rivers and lakes, which can cause harmful algal blooms. Scientists are also working on genetically engineered crops that tolerate drought, salt, and heat, crucial traits as climate change alters growing conditions. And then there's vertical farming, growing food in stacked indoor layers under LED lights, which dramatically reduces land use and can bring fresh produce closer to urban consumers. Next, we have cities and urban sustainability. Over half of humanity now lives in cities, and that's heading toward 68% by 2050. Sustainable cities are a huge focus of engineering and urban planning. Modern smart cities use networks of sensors to monitor energy use, traffic, air quality, and water systems in real time. Cities like Singapore are experimenting with district cooling systems where chilled water is produced centrally and piped to cool entire neighborhoods, slashing energy use compared to individual air conditioners. Architecture is going green too. Techniques like biomimicry, designing buildings inspired by nature, are leading to skyscrapers that ventilate naturally, like termite mounds or facades that mimic leaves to optimize sunlight and shade. Next, we have circular economy and resource recovery. Historically, human economies have operated on a take, make, waste model. We extract resources, manufacture products, and eventually discard them. The circular economy aims to keep materials in use for as long as possible. Engineers are designing products for easy disassembly and recycling, ensuring parts can be reused rather than ending up in landfills. One exciting frontier is urban mining, where valuable materials like lithium, cobalt, and rare earth metals are recovered from discarded electronics rather than mined from the earth. Even chemical recycling technologies are emerging, where plastic waste is broken back into its original polymers and monomers and repolymerized into new plastic, maintaining quality without relying on virgin fossil resources. Last, we have carbon capture and storage. While reducing emissions is a priority and it's number one, scientists know we'll also need to remove existing CO2 from the atmosphere to stay within safe climate limits. Enter carbon capture, utilization, and storage, CCS for short. Direct air capture plants like Climeworks Orca facility in Iceland use large fans and chemical filters to pull CO2 from the air. The captured CO2 can then be stored underground in basalt rock formations where it mineralizes into stone. However, this tech is expensive and energy intensive. So, a lot of research is focused on scaling it up and making it more efficient. There's also research into using captured CO2 to create valuable products like synthetic fuels, building materials, or even carbon negative chemicals, turning a pollutant into a resource. So, all this might sound daunting, but one of the most exciting truths about sustainability is that it's not only about sacrifice, it's about innovation and creating new possibilities. As individuals, we can make choices that add up, consuming less, reusing more, choosing sustainable products, or supporting policies that push industries to change. But that perhaps But perhaps even more impactful is how people can contribute professionally. Whether you're a materials scientist developing biodegradable polymers, an engineer designing energy systems, a software developer creating tools to cut waste, or a policymaker writing sustainable regulations, there's a role for everyone in building a sustainable future. At its core, sustainability isn't about giving things up, it's about redesigning systems so we can thrive without destroying the planet that sustains us. STEM gives us incredible tools to make that future real, from AI that predicts crop yields to synthetic biology that engineers bacteria to break down plastic waste. The challenge now is deploying these tools wisely and equitably, fast enough to secure our future. So the So the next time you see the word sustainability on a product or hear it in the news, remember that it's not just marketing. It's frontline one of the most important things that we need to prioritize. Thanks so much for listening to STEM Explained. If you enjoyed this deeper dive, be sure to check out my interview with the CEO working on sustainable business processes. The business is called Microt, and it's an inspiring look at how tech and innovation is transforming the corporate world. Share this episode with someone who's curious about the science behind sustainability, and let me know what other topics you'd like to explore. See you next time.